Hello, everyone. Welcome to this week's Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. As a heads up before we get started, the solution to the Spot the Vuln challenge will be covered in tomorrow's binary episode. And if you missed that challenge and want to take a look, it'll be in our Discord in the Spot the Vuln channel. And that Discord can be found in the description or in chat as well. I'll put it in there really quickly. But yeah, with that said, let's jump right into our topics for this week. First, we have a macOS Finder bug reported by SSD Disclosure. Straightforward issue to start us off with. Shortcut files for iNetlock can use the file protocol, which gives them the ability to run applications and such without the user's knowledge or consent. So anyone who sent an email to a Mac user with a malicious, how do you say it? iNetlock? I'm just going to go with that.
Yeah, that's
iNetlock file.
mentally how I've been saying it. iNetlock, iNet location. They're supposed to be the shortcuts to an internet location, so that kind of makes sense.
Yeah.
And yeah, I guess one thing of note is the fact that the way they replicate code execution here is those are supposed to be shortcuts. So when you click on it in Finder, send an email, somebody tries to open it, it'll open up whatever that URL is, and then that'll end up being passed out to like a default handler. So if you open like a file URL, that'll end up opening up, or you could use that to execute a local application calculator app as their example. And they also patched the vulnerability, um, but apparently they just blocked using file lowercase. So using file with like an uppercase F and L did get around that, or doesn't appear to be blocked according to the authors here. So not quite a complete patch.
The classic popping calc. Yeah,
I
that
mean,
struck me as very weird with how they didn't normalize the URI for the check. That seems like
especially as
really
a
weird
patch,
for Apple.
it's
Yeah,
just a poor move. Like that is such a classic bypass on that. Like just check it. Thank you next for the subscription. And that also reminds me, thank you Imperial G for the Prime sub also. Who
yeah, that was
subbed
awesome.
before went live.
Yeah, yeah, it's really weird from Apple because like we've talked a little bit negatively about how they've handled reports before in the past, but usually when they do handle them and fix them, I thought their patch process was generally fairly good, but this is like a pretty blatant miss to like lack the normalization for that kind of check. I mean, obviously, it's every company is going to make those kinds of mistakes. I guess it's just
It's
really
easy
weird
enough
to
to
see it from
make,
Apple.
but it's just the scenario around it.
Yeah,
That said, like I do kind of have mixed feelings about the issue itself because that is a bit of an ask to have. So if you could control arguments to the file being executed, that's a pretty different story. You can very clearly get arbitrary code execution in a lot of cases if you control arguments, but without controlling arguments, you pop calc. That's obviously not useful, and usually that's a stand-in for doing something useful. And in this case, and some we've covered a few other vulns like this. I'm just happening to call it out here. But, it's a bit of an ask to say you need a local file that's also going to do something useful or malicious, without any arguments.
yeah, you
Uh,
could totally take advantage of it. It's just not as straightforward as the vulnerability might suggest. Because, like you said, you would need some kind of app that does something useful that you could abuse without being able to control the arguments. So maybe if you can get an application launched that you know has a known vulnerability or something, maybe that could be useful. And then you could use that as like the first part of a multi-stage attack or something. But yeah, it seems hard to get something immediately useful from just this issue because, like you said, you would have to have an app installed that can already do something malicious to take advantage of this right away.
yeah, and like I said, we've covered other vulnerabilities like this before. I just wanted to bring that up kind of this time around, but it's still a bit of an issue. But it's not entirely arbitrary. Um, This said from Belika, use another app to drop a file and then run that. One challenge with that is sometimes you do need to know where that other file is going to go. So my thought was, okay, if you're emailing this inetlock file, you could email an actual file with it, but you're not going to know the directory that that goes into at the time that you're able to craft the inetlock file. There definitely are cases where you will have downloads that you could do that sort of attack, and that's I think going in line with what Spectre was saying too. Like you need something that's already there. You can use another app. In his case, he was saying another vulnerable app. But yeah, I mean, you could, have them download it with, Discord or something and put it on there. Like, there are ways to do it. It's just raising the bar. It's definitely a higher ask than, like, I don't know. I mean, it is technically RCE, but it's not ACE. It's not arbitrary code execution.
That's a good way to sum it up. Yeah. All right. So up next, we have an RCE in AWS Workspaces, being Amazon's desktop virtualization service. I don't know about you, Z. I didn't even know that Amazon had like desktop virtualization services available like that. It doesn't surprise me, but I've never really went out looking for it.
Yeah, I think
But
all the cloud providers have something along these lines.
yeah. So this is a post from Rhino Security Labs, and it affects the desktop client. One of the things that desktop client will do is it'll register a custom URI that can be used from the browser, for example, to launch a workspace, and that's through the workspaces prefix. It also allows parameters in that URI, and it doesn't properly sanitize them when launching the client, so you can pass arbitrary options to it. Where that desktop client is based on the Chromium embedded framework, by using one of the debugging related options like the GPU launcher, you can use that to execute arbitrary commands. Now, there is a bit of a catch there where you have to pass a valid registration code as a parameter, but an attacker can just place their own registration code in there to meet that, according to what they say here. So it's not really a huge roadblock. It can be gotten around pretty easily.
Yeah, it's
So
a restriction, but like I said, you can get around it. It's just that's I'd almost consider that more or less just formatting. Like, I mean, it is more than formatting, but effectively, it's not very much.
yeah, it's not going to save you. So yeah, I mean the main thing there is just the lack of sanitization that can lead to parameter injection. Fairly common issue that we've covered quite a bit on the podcast before.
Yeah,
This
it's
is
been
kind
a
of an
little
interesting
while.
application of it, though, um, and something like a virtualization service to the workspaces URI. That could be a like potentially more interesting attack. Like I don't know if that might be able to be used for like a Privesk or something. Um, as in like when you're talking about virtualization, usually it is running at a pretty high privilege level because it needs to. But I don't know the architecture of how their service is structured, but it was just something was kind of thinking about a little bit. It could be more than just RCE.
Well, because
Um,
it's coming through on the user, I can't imagine like Workspaces itself, like I mean, this is just communicating with the cloud for all of its virtualization. So it's not I don't think it needs to run with any higher privileges.
so I guess the kind of attack scenario I have in mind there is you can use RCE and then you already have a potential like an attack surface that you can use for a Provesk if you needed to, right? Like from that
Perhaps, but
virtualization environment.
I
Um,
don't think it necessarily even needs to run anything privileged. It should be able to do everything. That said, that's just speculation here because we have to look into how Workspaces works to decide
yeah,
on that.
yeah, that was just a thought I had when I was reading it. But yeah, overall, I mean, it's parameter injection, somewhat trivial issue, just an interesting product that I wasn't even aware existed. So,
Yeah,
that's
it's
kind of
been a
cool.
little while since we've covered one of these. Balika and Chad ask, can we do the same with 5M? Um, Possibly. Key thing here is that it can't be doing any escaping on the parameter, so you have to be able to escape and add your own arguments to the call. Does seem like it's a relatively common issue. Said we've covered. I want to say it was more in like early last year. We were covering quite a few of them. So I mean, there's definitely a chance at it, but I can't say for sure.
Yeah. All right, so let's get into a story with a bit of drama around it. Four zero-day vulnerabilities for iOS were dropped due to the researcher being Illusion of Chaos being unhappy with Apple's bug bounty program, specifically the fact that they reported these four issues back in March through May, and three of them still haven't been fixed. The other one has been, but it was omitted from their security notice page, and the researcher didn't get any credit for it. Now, we won't go too deep talking about Apple here in terms of their bug bounty program because we covered that as recently as last week, I believe, when we covered the Washington Post article that
Last week or
talked about
2
Apple.
weeks ago, where, yeah, we had our little rant against Apple on that one.
Yeah. Suffice it to say, generally, it's a negative view towards Apple's bounty program, and this kind of supports that. But yeah, mostly what we're going to focus on here is the actual issues. All of them were in Apple's XPC, which is their secure IPC mechanism, which recognizes things like entitlements, which,
Well,
for those who don't know, is like Apple's version of policies to define what apps can and can't do. Go ahead,
that
Z.
kind of, misses it a little bit. So XPC is the framework Apple provides for doing that sort of cross-process communication or inter-process communication. Um, it's in various Apple services that use XPC. Like anybody can write an XPC service that exposes whatever functionality. So in this case, it's the gamed any helper and the analytics um XPC services rather than like it's not in XPC itself. The issue is with the services running over XPC. The fact that they don't do appropriate permission or entitlement checking.
Yeah. Um, yeah, XPC is kind of like a built-in gRPC. For those who are familiar with that, it's kind of got that same idea of running services and passing messages between them. So yeah, as you said, the first issue here is in the game daemon or game D. The issue is the game D service just doesn't check the game center entitlement properly, meaning any app can invoke methods like authenticate player with existing credentials, um, even if they don't have that game center entitlement. And that method returns an object containing the Apple ID of the user, as well as a game center token and a directory services identifier. So it returns some useful information that you could use as an attacker. Um, there's some other interesting parts there too, though, where even if the game center is disabled, where you would think that this wouldn't really work and that the game daemon wouldn't be useful to you, um, there are some other useful things you can do still, like read arbitrary files outside of the app sandbox. And that's by using the request image data for URL method in
Well,
the GK utility service. And that can be leveraged to do some other things like read property lists and databases of contacts,
yeah, so
which gives you the useful angle to it.
it's not entirely arbitrary files outside the sandbox. It's arbitrary files inside of the mobile Gestalt cache library. Uh caches folder there. Might not be specifically that folder, but it is within like a subgroup of folders that you're able to request. You're requesting image data for whatever URL in those in the subdirectories the service can access. Um, so there are still some restrictions there, but they do use it. Um, like they get access to the core duet database, and then they use a similar vulnerability to get access to the speed dial database as being kind of the more sensitive things that they were able to get. That's not completely arbitrary in terms of what they can access outside of the sandbox.
Yeah, it's fair to point out. Uh, yeah, thanks for pointing that. Um, but yeah, the other thing is too the cache image data method might be able to be used to write data outside of the immediate app sandbox. Though I think the stipulation you pointed out still applies there. They note that this issue in total would be worth about 100K, and that's based on Apple's own bounty program where they specify sensitive information that's usually protected by the sandbox being accessed. Now, that is a maximum amount, as I understand. It's possible they could pay out lower than that, and they probably would if they, if we imagine a different universe where they were actually paid out for this. But yeah, that's the main thing that they're upset about here. Is in this case, it seems they didn't even recognize the issue. So um, yeah, bit
Yeah,
unfortunate.
so I guess in fairness here though, when they defy insensitive data, they do have a note here about what is included for that. And broad access, for example, full databases from contacts, mail, messages, notes, photos, or real time or historical precise location data. And I feel like that's where they're getting him payout. He's getting access to Core Duet, which has some contacts in it, and he's getting access to Speed Dial, which has some contacts, but it is not the full contacts database. And I think Apple's maybe a little bit in the wrong for trying to very strictly define it rather than by the actual impact. But that is kind of what they've got here as a note is top payout, broad access, full database contacts. Like they have a limited set of things that they're considering as sensitive data, even though you would generally think like sensitive data is well, if they care about contacts, they should care about contacts in any form, including like speed dial. But I mean, speed dial, I guess, would be a bit more limited. I'm not sure how limited the access on the Core Duet database was. I tried looking into that a little bit, uh, but I wasn't able to figure that out.
But yeah, I mean, so the the thing is here, like Apple's big thing is they like to push privacy as their main selling point. So it does. I do kind of blame Apple a little bit here for not accepting this issue, even if it is a little bit out of scope. It
Oh
feels
yeah,
like
I'm
they're following the
not.
letter of the bounty instead, or the letter of the law instead of the spirit of it. That's how I'd put it there.
Yeah, that's
But
exactly what I was getting at. Like, it feels like they're just defining it down and like getting them on a technicality. Not
yeah,
like I agree with you. I feel like like Apple should be considering the impact of it rather than just the technicality that well, it's not really the contacts database, so that doesn't quite count. But
yeah.
moving on, the other vulnerabilities were very similar. Um, any helper, you could enumerate the applications installed, because it held some sort of cache that you could basically inquire about. You could give it a this cache command set to 3, and the cache signing identifier would be whatever application bundle ID you were interested in. And if it responded with the cache information that it has on that application, you know that they have it installed. And it should have been, I think, looking for. Okay, no, that one doesn't have any particular entitlement that it needs. But the next one, the Any Helper Wi-Fi info, that service, similar issue. Um, Again with XPC service. This time it didn't check for this networking Wi-Fi info entitlement. Only if you sent it an SDK version value less than 524288. So you send it, SDK version 1, and it just won't check that. Probably because I'm assuming that entitlement was added then, but yeah, I don't know. I mean,
I'm guessing it has to be some kind of compatibility thing. Um, but it is like this is a pretty significant issue too because any app that can access that service can get Wi-Fi information, like the SSID and whatnot, without the entitlement.
yeah, it
It
fails
does
open.
seem a little like a little interesting to me that they have like that compatibility type check built in. Um, I'm surprised, especially after a certain amount of time, that they wouldn't have just made it mandatory in general and just because Apple is not above just deprecating things and making them not work. You know, it's not like Microsoft where they want to support things from like 30 years ago
But
on
that's where I
modern
don't know
systems.
how old this SDK version 524288 is. Maybe it is relatively recent. We're still kind of in that middle period where a lot of applications are wouldn't be written expecting access to that and not having it.
Yeah, that's
Like
fair.
I don't know on that. I could see why like the logic there, but unfortunately because that is just application control, that means any application can decide. Yeah, I mean we're just using SDK version 0 or 1 or something and get around it that way.
Yeah. unfortunately, where we don't do Apple stuff, it's hard to know exactly what that value is. The way I read it was like using the first number as like the major number, so like iOS 5, but that would be a long time ago. I mean, they're up to iOS 15 now, so yeah,
But
I
that
don't know
feels like
exactly what
something
that
that
SDK version is.
could have been
Yeah.
introduced back then too. I just don't know the numbers. I didn't. I probably should have looked that up. I didn't. So we're kind of left with that speculation.
On that note, though, if there is anyone like watching, uh, who knows like roughly what iOS version that SDK version would be tied to, I would be interested to know that. So if you could leave a comment or something in the Discord, that'd be really cool.
Yeah, like in
Um,
fairness, I don't think Wi-Fi information like that feels like something they would have privileged off quite a while back. Like one of those more obvious cases to had a privilege check on or entitlement check on. That said, I do think, or moving on from there, the more serious vulnerability, or most serious in my opinion, was this analytics one where you could just send it the I say the command log dump. I mean the parameter that it expects is command send a log dump, and it gives you basically all the analytics. So that includes things like medical information that it might have collected. So if you have it linked in or tied in with a Apple Watch, which does the heart rate, you can get someone's heart rate information, device usage, crashes. Obviously, are going to be an analytics information. Um, just a ton of personal or potentially personal information in there.
yeah, and notably, that's even if the share analytics option in settings was toggled off. Um, that just didn't seem to be respected here. It would still share that information, which is pretty wild. Um, Understandably, I guess to some degree, that last one was fixed in iOS 14.7. Um, and the reason I said like understandably, I guess, is it's the only one that was fixed out of the four bugs covered here. So I guess if you had to pick only one bug here to get fixed, that would definitely be the one. It is the most impactful one in terms of the types of sensitive information that's disclosed. Um, but yeah, I mean, iOS 14.7 fixes the analytics statement one. The other three are presumably still 0 days. I haven't seen anything. Oh, wait, okay, sorry. So the timeline does mention. Does it mention that the other ones have been fixed? I just wanted to quickly check that.
No, it only mentions the iOS 14.7 fix.
Right. Okay. Yeah. So what got me a little bit confused in the timeline was I forgot. They point out like all the security content lists that went out afterwards that never even pointed out uh the issue that got fixed, the analytics statement one, because he never got credited for that one. So yeah, they keep publishing these security content lists, and that vulnerability is never mentioned in any of them. So and that's still true to this day. So the one issue that was fixed, Apple doesn't want to acknowledge was even an issue publicly. So man, it's hard to really give them any like give Apple anything good to say here. But um yeah, I mean the issues were a good example of just why centralizing these types of permissions checks into something like the service manager makes a lot of sense, because if you have to rely on the services to do that checking individually, there's bound to be some areas where they're just not going to do it, or they're not going to do it right. So
Well, I mean, still in this case, obviously they're not sent, or they're only checking it for. Well, they're checking it with the commands that need it, so that does kind of make sense, or that does make sense. Um, it's hard to centralize this exactly. Like you can do some weird way of probably pulling it out, but doing it in line because everything has different entitlements, doing it kind of with like, I mean, you might want to pull out what entitlements different commands have and have somewhere where that does get checked as a central thing.
that's
That
kind of
could
what I was
perhaps
thinking.
be done like configuration.
Yeah, that's along the lines of what I was thinking of how to
Yeah,
prevent
that's
these kinds of issues.
That is a bit more ideal. Also makes it really easy to audit whether or not something has a permission or has it wrong or right.
Yeah, you could just knock those out uh, with an audit on that. But yeah, I mean, a fair bit of these issues are not super um sensitive, I guess. Like the game D one, like yeah, you can get the speed dial and the contact information for some people on it, but it's somewhat limited. Um, the analytics one is the big one though. That's a big problem. So
Uh,
at
the
least that one's fixed.
the ability to enumerate what applications are installed, that could be reasonably damaging. Like that's similar to knowing what website somebody visits. Like in certain countries, that can be very useful information and somewhat dangerous information to share.
You know what? That's a fair call out. Yeah, that's true. I wouldn't say it's as sensitive as browsing history, but yeah,
No,
it
but
maybe is a bit more sensitive than what I gave it credit for.
it
So,
can reveal things about the user.
and
Um,
it could be used for fingerprinting too. I mean, we've seen that done before, where there was a side channel. I forget exactly what the application was, but there was a side channel where you could probe the applications that someone had installed, and they demonstrated how that could be used to fingerprint people, track them. So, yeah, I mean, it can definitely be leveraged. But yeah, let's go ahead and move on to some RCEs that were found in NPM. So NPM is a package manager for Node.js stuff. This has $15,000 worth of vulnerabilities in it, discovered by Robert Chen and Ginkoid. They found 5 RCEs, which involved escaping an extraction path of tar archives, which are extracted with the Node tar library. 2 of them involve mishandling of absolute paths. 3 of them are symlink related. Getting into the first two that involve absolute paths, the first issue is how they attempt to strip root from the absolute path. Basically, they strip it once, but you can just add multiple slashes at the start so that when one gets stripped, the next one doesn't. So if you pass a double slash, a slash will get through. 3 slashes, two will get through, etc. Um, the second issue was a bypass around the patch to that, which was basically refactoring that path check into a separate file and continuing to strip the root from the path iteratively while it's marked as absolute. That was better, but it still failed to consider some of the other edge cases. Um, the is absolute function is OS specific. They mostly focus on Windows here. But the edge case they fail to consider is what happens if you try to resolve a path using multiple arguments. Well, the absolute path will take precedence, and any non-absolute paths will join it. So
so
by passing a C directory, then an argument that goes up a directory, for example, that can bypass their intended
I
fix.
don't know how useful this. So this is poorly written post. I mean, just to be frank, it's there were so many things you had to kind of struggle to understand why they're including this information. To some extent, this is kind of part of it. So yes, they talk about using this path.resolve, which they mention that um Node R does not directly use, but also then they mention like, well, maybe these other things use it internally. And you were just talking about that difference with the or having multiple arguments here, where they pass in the 2 arguments here, D games and like C or whatever, and or sorry, the where they see that where we'll backtrack in the second one, and they'll kind of merge them. Like that true resolves doing that. File write sync does not do that though. Um, that was kind of my understanding was, well, they're saying that file write sync, does that, but no, file write sync only takes in the 1 argument file name and doesn't accept the array as a file name. Or at least maybe that is in a later version of Node. If it does, I apologize, but I tried it on my locally installed version of Node. Um and passing in an array there didn't work. So I'm not sure exactly why that was chosen as what they were showing. Um, so
So yeah,
Bleak mentions. Oh, go ahead.
I was just gonna say I was a little bit confused too because, like you said, unfortunately, it is a bit poorly written. Um, but the fact that it was accepted by and it was reported previously by a member of the GitHub security team. So that does make me believe that there is some area that could take advantage
So
of it.
is the not
But
the issue actually this path separator style here? So doing C colon slash slash A, basically they end up getting the so the actual issue here, I believe, is the fact that when it's looking and stripping out the relative paths, like the dot dot slash, it's expecting dot dot slash to exist as either the start of a string or like in between file separators, so slash dot dot slash. And then because it's not, I'm just taking a look here to see if I could find where I recall them mentioning this. But I believe the issue was actually just like the final issue that they used was just the fact that you could start the path, so the C colon as like your root that gets stripped, and then dot dot slash, and it won't detect the dot dot slash anymore.
yeah, so that one kind of broke down to two issues that I understood it. The issue you just pointed out with not stripping out the dot dots in between the drive letter, um, and the fact that the precedence issue that they pointed out. But it's a little bit hard to tell because, like you said, they don't really clarify on um, how they actually exploited all the things
Well,
they talked about there.
this one
So
they do talk about their actual exploit is using the C colon dot dot slash. And yeah, note even I did find what I was looking for now. Note even though double dots are filtered out, the regex only matches double dots between path delimiters and the start end of strings. So this, I believe, is what their actual escape was. All of this content about using resolve and passing in something separate later as overwriting that, which by the way is a somewhat common, not I guess I won't say common pattern, but we've seen it before where joining paths. I want to say it was in Golang and I believe it's patched now or changed or something. Where if you would join paths, it would if you join a path with a absolute path, the absolute path ends up taking the precedence. Like it's just a little gotcha that you might not be expecting an absolute path there. And that seems to kind of be what's happening here, where just that absolute path ends up taking the priority.
it makes
Although,
sense when you think about how paths work, but like you said,
yeah,
it is just something you might not think about.
yeah. Although the case of the first case they show where uh resolving it with the C as the root, like root drive dot dot slash A actually ended up combining kind of with the prior path, and performing that traversal up. That was a little like it makes sense when you think about the C kind of maybe getting stripped or ignored and seeing that, but it also feels like that should be treated like an absolute path and it should just be like I don't even know where that should point to in fairness. 'Cause, you're traversing, I guess it should point to root. You can't traverse beyond that. So that was actually a little bit surprising to me. I apologize for our listeners, by the way, because I'm highlighting things on screen to show what I'm kind of talking about. It's hard to describe it every time though. But yeah, as on a whole, like this post was very unclear at times. A lot of struggling to figure it out.
Yeah. One thing I did want to point out though is because of like you were kind of isolated to that case where it has to be after the drive letter and not at the start of the end of the strings or between path separators, you are limited to only being able to use it once. So that kind of limits the impact. You can only write into paths one directory up, which they point out towards the end of covering that issue. The other three bugs were more akin to what you'd expect with this kind of attack surface.
Jumping back, sorry, just on that last point, something they
Yep.
don't comment on explore. So they comment on exploring just using a symlink, writing a symlink. So like the one dot slash writes into a symlink or one directory up. Another thing though is that one directory up, I think should be because this is in NPM. It's extracting packages, I presume, into like the package folder. Would that not bring you one directory up so you can now technically overwrite like any package file? Like that feels like a reasonably viable attack to overwrite like some common file, although maybe it is a subdirectory under there, so it isn't as useful. That's probably the case, but my thought is it might be extracting to the root of the package.
Yeah, so they note because the extraction occurs in a node modules directory, we're only able to write into other installed
Uh
packages,
yeah.
which doesn't give a direct path for escalation. So yeah, but yeah, the other three issues start to get into the cache implementation for the directory cache, and that's where the more common types of bugs with extraction come into play with using symlinks and hard links. So they do try to check against symbolic links and hard links in the archive by verifying folders against them. Sorry. And they also maintain a cache of pre-created directories for performance, which skips those symlink checks. And when an entry is symlinked or changed, it never gets removed from that cache. So the third issue here was fairly obvious when you take those two things into account. The directory cache never purged entries on folder deletion, so by just changing an existing directory to a symlink, you could access arbitrary files.
Well, I think that's almost a fair. So obviously it's a vulnerability. I'm not gonna debate that one. But as a developer, thinking about you're doing a file extraction, like I could completely understand why a developer wouldn't really be thinking about deletion because you're not deleting anything. Um, you're
Not in a
extracting all
normal
the files.
situation.
Yeah, like normally it's just files that are going out. Like you're not going to remove it, but you could overwrite a directory with a sim or well with anything, but with a symlink case. Like I get why a developer wouldn't really have that on their mind. I probably wouldn't, in fairness.
Yeah. So after they tried to patch that, which they did by removing entries from the directory cache when an entry is no longer a directory, um, they tried to do that, but that code ended up being broken because there was a desync in how the path was normalized between adding it to the cache and removing it from the cache. When adding it to the cache, it would convert the separators to forward slashes, but when removing them, it used the system path separator, which on Windows is backslashes for whatever reason. That is another ongoing debate, I guess. I don't know, probably not really being argued anymore, but I still think it's kind of dumb. On Unix, though, a similar problem existed where you could create files with backslashes in them, and there were no checks performed on that. So that was bug number 4. After that, they did some further patching, NPM that is, to try to prevent that issue. But there was another bug. Um, they tried centralizing the normalization of paths into helper functions and whatnot. The last remaining issue was on macOS though, because on macOS they attempt to normalize Unicode, and they had that same kind of problem. There was a desync and the normalization between adding it to the cache and removing it. Though that one seemed to be specific to macOS. So
Yeah, and
yeah, I mean, just a series of patches or attempted patches and just circumventions around them because paths are hard, evidently.
I mean, it definitely can be. I think ideal case is letting the system try and resolve things. And then using kind of how the system itself, normalizes it or doesn't. So, like, there is the concept of a canonical path. That's kind of what should be used in general when you want to find uniqueness. And that's also a fair way of like looking for directory traversals is once I resolve this path that I'm going to write to, is it still inside of the folder I want it to be? Like taking advantage of what the systems provide instead of trying to parse paths manually
Yeah, it's kind of
is
funny because we've seen some similar issues before with like symlinks being switched out and whatnot on Windows. And that was the fix in that case, was just using the system to resolve those paths for you. Um,
This does remind me a lot. It was either like it was a code execution. It was in like Git, I think, like just plain old Git when it was extracting things. It had a similar deal where you could mess with the cache by overwriting a directory with a symlink and then be able to write out into a symlink because it cached the results of stat to know if something was a symlink or not. And then there was some trickery to get the write to happen late enough. There were various things with it, but like this bug reminded me a lot of that Git bug.
yeah. Um, but yeah, I do find it interesting that they just. Sorry, one sec. The weather's messing with me today, apparently. But yeah, like it is kind of interesting that they just kept kicking at the wall, trying to continue with their own implementation, continue with these patches instead of just using the system resolving. That could just be a decision that they made. Um, just with like whatever situation they were in, maybe they didn't want to do that for some reason, but it was something that I kind of questioned when I was reading through it. But yeah, I mean the most fun part of this post for me was definitely the cache desync. That's just kind of a fun issue and one that can be easily overlooked from a developer perspective. I do wish some of the earlier vulnerabilities were explained a little bit better because I think the cache section, like the last three, were explained pretty well. It was mostly the first two, or actually mainly the second one, that I think just needed a little bit more explanation as to um, how what they were talking about could be
Yeah,
utilized. But
I mean, for all I said about like it felt like there's a lot of information here. It just felt like there was a lot of it was kind of a lot of roundabout things that seemed to exist or be stated rather than I guess a bit more direct, and that just made it a little bit more complicated to follow his same thought process to understand what's necessarily going on. Like all the bugs are explained reasonably well. It just took some extra effort to kind of figure out exactly where he's going with it.
yeah, that's a good way of putting it. All right, so we'll move into our last topic of the episode here, which is Apache Dubbo. All roads lead to RCE. This is a topic from GitHub Security Lab. It details 13. It talks about various vulnerabilities in Apache Dubbo, which is Apache's Java-based RPC framework. So this post is very long since it goes in depth on multiple vulnerabilities. Some of them being pre-auth, others being like semi-auth, as we call it. So yeah, Z, I'll let you take this one away.
Yeah, of course, he'll give it to me because there's more villains here.
More work. I'll let you take the work.
Yeah, no, this is actually pretty easy to summarize despite all the vulnerabilities. And with that, like one of these has like A inside of it, but they all basically filter down to talking about needing to understand the entire attack surface and in large part just discovering different routes to the deserialization code with attacker controlled code. So initially there have been some deserialization bugs inside of these RPC calls where invoke an RPC call and you get completely arbitrary code execution within the Java or like calling Java deserialization, so effectively RC, but takes a little bit of work to turn that. Because I don't think there's a generic Java deserialization gadget, but something like Apache, there's more than likely enough there. Like there is an RCE gadget. Um, so prior bugs have been reported here, and then they went and added in this allow list to think Hessen too. I actually wasn't familiar with this particular serialization format. But they went and added like this allow list into it and tried to fix them, but they found other places where you could deserialize content that didn't require actually passing through the RPC calls. And as a post, I love the fact that he talked a lot about going to pimp for CodeQL here a little bit. Um he talks about a lot in terms of using it to assist with the research, to find attack surface, to let it discover where things flow into other areas. So all of these generally just come into different routes. So I'll let you kind of read about all the different routes that he found within I don't know, Spectre was saying Dubbo. I kind of was thinking Dubbo or yeah. Uh I'm not sure exactly how it said, but I'll let you guys read on that. None of them were too interesting. One example here was basically found, most people were sending and testing with requests that start with 0x ADBB, which is kind of what the normal RPC invocation starts with. It's what you kind of expect, but anything that doesn't start with that gets handled by this telnet codec. And lo and behold, you look at telnet codec, and suddenly there's all sorts of requests, and you can actually even send some of the responses to it that it'll process and try and parse, and it'll deserialize those. Then he found like a generic filter where you can specify what sort of filter or basically you could specify the sort of serialization that it should use to decode. The generic filter is it'll use reflection to figure out your request comes in, uses reflection to figure out what service it's supposed to go to. So this generic filter does that, and it'll read how is this information serialized, and you can tell like native Java won't actually accept that unless it's being asked for. But there are other options like being um, and raw was another one, or just having the attachment return true was another option, and those get invoked by effectively a hash map. You set a class in there and tell what class to invoke. So if you've got like an RCE gadget, you can invoke that single class using this. Oh, there's another one, I think, like the telnet handler using the bean version. Again, just finding new attack surfaces. Two things kind of stood out to me as actually interesting out of all of this. I was just seeing how somebody else was writing their CodeQL queries. And that was one. There were 3 RCEs, but not pre-auth. So everything I've talked about so far has been pre-auth, although I've kind of just mashed them all together. Uh, these 3 RCEs were kind of pre-auth, kind of not. They were in configuration, so the configurations would be in a YAML format, and it would send out these updates saying like, "Hey, this configuration update, this value changed. Let's make use of that." So you'd get that, and from that point, basically, since it's YAML, it'll insecurely deserialize YAML, and again, codex use. What's interesting though is the fact that a lot of the configuration managers, by default, according to the author, run without authentication. I find that a little bit crazy.
Insecure by default. It's the new thing. You didn't know?
Like,
Um,
it
yeah,
makes
no, that
sense
is kind of
for
bonkers, though.
it makes sense, like, if you talk about, okay, the file system configuration manager. Like, I'm assuming that is reading from the file system. Fair enough that it's not doing authentication to make sure whoever edited the file was authenticated or something. That's a bit of an ask. But some of the other ones, I don't know. It feels like there should be some authentication on some of these services or on some of these configuration managers. So that was interesting to me. I haven't used this before. I haven't even done. They say it's quite popular, but I don't even recall having any engagements where I've naturally interact with it. So I'm not too familiar with how you access the configuration managers, but the lack of authentication there is interesting, we'll say. One of the other attacks they found, which ended up being in script routes, you would have or you could, define certain routes as goes to this service, whatever. But you could also have scripted routes where all of the clients will download these scripts and execute them to determine what the routing is. So effectively, if you control that, gain some authenticated access. Like this is still part of like the configuration. Then all of the consumers will go ahead, download it, and execute whatever script. So this does have to be a script that runs inside of like the Java runtime. But there's a lot of languages that you can get supported for that. Yeah, it might have a bit of an ask for like most consumers probably aren't just going to be sitting there with like Iron Python installed or something, or sitting in the class path. So there is a little bit of an ask with that, but you're going to know what's available depending on the application you're targeting. I just thought it was interesting to have that sort of, all the consumers download and get impacted by it. Like you can kind of worm its way. Well, not really a worm, but it can spread that way and attack a lot more clients than just a single RCE.
Yeah. So there was one final issue that we thought we'd talk about just because it was found after reporting the other issues to Apache. And this is when they went back and looked at the changes in 2.7.9. It's another deserialization issue, but it also involved a desync to allow it to be hit. Um, so some of the changes that were made after the other issues were reported were things like the addition of the new a new codec support get serialization method, which only uses the server specified deserialization format instead of allowing the user to specify. They also moved the security checks away from the get serialization method mentioned, which took the protocol ID, and they moved that into check serialization, which takes the path, version, and serialization type. So they looked at various functions that called that. The decodable RPC result decode was one, the exchange codec decode was another, and the decodable RPC decode. The first two weren't really interesting because of how the serialization type was verified in both the invocation and response. And the exchange ensured the serialization payload was really small at less than 50 bytes. The decodable RPC decode was interesting though. And the problem comes in when looking at that check serialization method when it's called from the decodable RPC decode. And that is that check serialization will try to check the type against the service to ensure it's allowed. But to do that, it takes a path and version pair. And if that pair is invalid, such as by providing a bad version string, it just fails without throwing any exception. And that's problematic because the exception is what that decode method relies on to know that it's invalid. Um, and furthermore, the decode method doesn't use that version string to look up the method to call. It just uses that path.
And that
So
key
by using a bad
difference,
version, it allows a bypass of the check serialization method. Go ahead, C.
yeah, that key difference there and how it's doing the lookup where one expects the version, the other doesn't, really kind of creates the vulnerability. Like that, we like using the term, but that desync between the two lookups.
We
Um,
love desyncs here.
oh, yeah. Uh, yeah, I mean, I thought this was probably the most interesting vulnerability in the set of them here because it is different. I mean, we don't tend to talk a lot about the deserialization vulnerabilities anymore because a lot of them just tend to kind of be that same old thing. You have an input that goes a place that can be deserialized. And talking about the actual deserialization gadgets is getting really deep into the weeds of a specific exploit and a specific attack. Um, so I tried to kind of cover those at least briefly, but this one, at least, it's something different in terms of how you get there. I thought it was interesting though if they would like it feels like one of those things you should just kind of universally provide it instead of just assuming a version, but I kind of understand why they'd have the two interfaces or the
Yeah,
two different options to call that function.
yeah. It's RPC. Like when you look at the architecture of how Apache Dubbo works, which I think they do cover further up when they cover like all the components involved. It does get pretty complex. So um, yeah. But yeah, I mean, they mentioned there were 13 vulnerabilities. I don't think they cover all 13 in depth in this post. I think they cover they cover most of them, but I don't think they cover all of them. That said, like Z said, we didn't want to go too in depth on all of the issues, but our vulnerabilities page, with which Z recently started up a couple weeks ago, that will have some summaries for some of the issues there. So if you are interested and you just want a quick synopsis without reading through this insanely long post, be sure to check out our website after the episode goes up, and those summaries will be there. So I just wanted to call that out because we did do some summaries for some of them. So but yeah, I don't know if you have anything to add, Z, but if not, we'll go ahead and wrap
Oh,
it up.
uh,
All right,
our last topic.
cool. So thanks to everyone who tuned in. You can catch the VOD on Twitch or on YouTube at 6 p.m. Eastern tomorrow. We will. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. Feel free to join the Discord and follow us on Twitter. Links for those are below the video. Also, tomorrow we'll be back for the binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific. That's also when we'll be covering the Spot the Vol solution. And we'll see you all then.